an equilateral triangle, in an equilateral triangle, all geometric centers, in an equilateral triangle, all geometric centers lie on the same point. In an equilateral triangle, all geometric centers lie on the same point. In an equilateral triangle, all geometric centers lie on the same point. If I take an equilateral triangle or an equiangular triangle, all the three are equal. AB equivalent to BC equivalent to AC. So if I drop a perpendicular, all the geometric centers lie on the same point. All the geometric centers lie on the same point. If a centroid lies here, orthocenter also lies here. Orthocenter also lies here. Circumcenter also lies here. Circumcenter also lies here. And incenter also will lie here. Very, very important point. In an equilateral triangle, all the geometric centers lie on the same point. All the geometric centers lie on the same point. In an equilateral triangle, all geometric centers lie on the same point. In an isosceles triangle, they lie on the same line. In an isosceles triangle, geometric center lie on the same line, and in an equilateral triangle, they all lie on the same point. They all lie on the same point. Isosceles triangle, geometric centers lie on the same line. In an equilateral triangle, they all lie on the same point. Sixth point, conceptually starting from basics, this entire week, if you keep listening to my classes, probably I am planning to take close to 300 to 350 questions only from geometry and mensuration. Right, this topic I covered some weeks before, but I am doing a recap so that if I take circles or mensuration, you will not think that, sir, from where you got it. I hope it is clear. Entire week mensuration, minimum 12 hours I will take it. Ajay sir will take simplification for 8 hours and partnership also. English sir also have confirmed the schedule. Tuesday and Friday evening 6:30 to 8:30 he will take 2 topics. Today evening there is a class, mandatory attendance. Do not miss listening to a verbal class from an IIM Indore and a Stanford alumni. He will be taking para jumbles today, and Friday there will be a topic on para completion. Para jumbles and para completion. So, and I will also ask Krishna sir to take 1 or 2 reasoning classes. He promised me that he will give time for my kids, minimum 4 to 6 hours. Minimum 4 to 6 hours this week. I told them my students are writing the examination. They are asking few topics. Generally, I do not try to give over promises to the students. Let us keep the expectation very low. And I know I am reading all the feedbacks of various students. I will incorporate the feedbacks. If you trust, don't doubt. If you doubt, don't trust. As simple as that. Now, sixth key point. Sixth key point. Listen carefully. Suppose if I take an equilateral triangle, ABC is an equilateral triangle. ABC is an equilateral triangle. ABC is an equilateral triangle. In equilateral triangle, all geometric centers coincide at the same point. AD is perpendicular. Yesterday we discussed AD is perpendicular to BC. AD height is given by root 3 by 2 into side. Yesterday we discussed height of an equilateral triangle is nothing but root 3 by 2 into A. Now see, join all the vertices. This will become circumcircle. Join all the sides of a triangle. These will become incircle. Now if you observe carefully, one by one we will discuss. The top one is nothing but the radius of the outer circle. Bottom one is nothing but the radius of the smaller circle. Now if you see, already we discussed centroid divides median in the ratio 2:1. So AG is to GD is nothing but 2:1. So AG is nothing but 2 by 3 into AD. AG is nothing but 2 by 3 into AD. 2 by 3 into AD is nothing but root 3 by 2 into A. 2 cancel. AG is nothing but R. Capital R is nothing but A by root 3. Capital R is nothing but A by root 3. Similarly, if I keep GD, GD is nothing but 1/3 of AD. AD is nothing but root 3 by 2 into A. Root 3 by 2 into A. What is GD? GD is nothing but small r, which is nothing but A by 2 root 3. Extremely important key points. Circumradius is given by A by root 3 and in radius is given by A by 2 root 3. This is for an equilateral triangle. For an equilateral triangle, circumradius is A by root 3 and in radius is A by 2 root 3. Circumradius is A by root 3 and in radius is A by 2 root 3. In case if you find it difficult, you can use this concept and you can find out circumradius and in radius. Circumradius is A by root 3 and in radius is A by 2 root 3. Circumradius is A by root 3, in radius is A by 2 root 3. Now listen carefully. R is nothing but A by root 3 and small r is nothing but A by 2 root 3. If I divide 1 with 2, R by R is nothing but 2. Ratio of the circumradius to in radius. Ratio of the circumradius to in radius. Ratio of circumradius to in radius is always 2. The value comes out to be 2 only in the case of an equilateral triangle. Ratio of circumradius to in radius. Ratio of circumradius to in radius. The value comes out to be 2. The value comes out to be 2 in the case of an equilateral triangle. In the case of an equilateral triangle, the value comes out to be right 2. I hope it is clear. What is that we have discussed? R by R is greater than or equivalent to 2 we discussed. So R by R is greater than 2 for non-equilateral triangles. For a non-equilateral triangles, ratio of circumradius to in radius. Ratio of circumradius to in radius is always greater than 2. Other cases it is equivalent to 2. Then we will start with the problems, which is orthocenter. Orthocenter is nothing but the point of intersection of altitudes. Point of intersection of altitudes is called orthocenter. Altitude is nothing but a perpendicular. D is nothing but A, D is nothing but C. Drop a perpendicular, these drop another perpendicular. There is a difference between perpendicular and perpendicular bisector. Perpendicular bisector will divide the line into 2 equal parts. But altitude is nothing but AD is nothing but perpendicular to BC. BE is nothing but perpendicular to AC. CF is nothing but perpendicular to AB. AD is perpendicular to BC, BE is perpendicular to AC, and CF is perpendicular to AB. The point of intersection of all the perpendiculars. Point of intersection of altitudes is called orthocenter. Point of intersection of altitudes is called orthocenter. This H in similarity I will discuss this one, sir. AH into why it is obtained we will discuss. AH into HD is nothing but BH into HE. and it is also nothing but CH into HD. Just write in bracket, it is based on similar triangles. Similar triangle. There are some similar triangles here. I will again come back to it when I am solving problems. AH into HD is nothing but BH into HE is nothing but CH into HD. Point of intersection of altitudes is called orthocenter. Point of intersection of altitudes is called orthocenter. Orthocenter is nothing but the point of intersection of altitudes. Another very important observation. Angle BHC is nothing but 180 minus angle A. I will prove this when I am discussing the similarity. AHB is nothing but 180 minus angle C, and AHC is nothing but 180 minus angle B. Very important point. BHC is 180 minus angle A, AHB is 180 minus angle C, AHC is 180 minus angle B. Very important key points related to orthocenter. Important key points related to orthocenter. AH into both are based upon similar triangles. When we discuss similar triangles, we will discuss the proof. AH into HD is BH into HE equivalent to CH into HD. Very important key points. Very important key points. Last key point before we get into problems. In a right angled triangle. If you observe, this is 90 degrees. So this will become height, this will become height. Orthocenter is at the point where the right angle is formed. Orthocenter is at the point where right angle is formed. Orthocenter is at the point where the right angle is formed. Very important point. Orthocenter is at the point where the right angle is formed. Please write. This is in the case of a right angle triangle. We discussed one more thing. In a right angle triangle, circumcenter exists exactly at the midpoint of hypotenuse. Circumcenter is at the midpoint of hypotenuse, and in an orthocenter it is at the point where the right angle is formed. I hope it is clear. Suppose in the case of a right angled triangle, this is 90 degrees. This is nothing but the circumcenter. B is nothing but the orthocenter. D is nothing but the circumcenter. If I join this both, if I call this as P, area of triangle ABC. Area of triangle ABC is nothing but half into product of the sides where the right angle is formed. Half into AB into BC. It is nothing but half into base into height. Base is AC. Height is nothing but BD. So very important point. The distance between orthocenter and circumcenter. The distance between orthocenter and circumcenter is given by BD is nothing but AB into BC by AC. AB into BC by AC. AB into, it could be any perpendicular, sir. This D could be the circumcenter. It is just nothing but a perpendicular. BD is nothing but the perpendicular drawn onto hypotenuse. It might touch the circumcenter, it might not touch it. I hope it is clear. Perpendicular drawn onto the hypotenuse. BD is given by AB into BC by AC. AB into BC by AC. AB into BC by AC. Another two concepts we'll solve, then we'll get into problems. or right angle triangle, orthocenter exists where the angle 90 degrees is found. 90 degrees is found. Last two key points. One is a sine rule and another is cosine rule, because we are going to use this both. Sine rule and another is cosine rule. A by sine A equivalent to B by sine B equivalent to C by sine C equivalent to 2R, where R is the circumradius. Sine rule. A by sine A equivalent to B by sine B equivalent to C by sine C equivalent to 2R. This is the sine rule. Sine rule. All these key points we are going to use it. All these key points we are going to use it. Cosine rule. Cosine rule is nothing but if it is A, D is B, D is C. D is small b, D is small c, D is small a. Cos A is nothing but, in one of the previous classes, I discussed the proof. B square plus C square minus A square by 2bc. You can, if three sides are given, you can find the angle. Cos A is nothing but B square plus C square minus A square by 2bc. Similarly, cos B is nothing but A square plus B, C square minus B square by 2ac. A square plus C square minus B square by 2ac. Cos C is nothing but A square plus B square minus C square by 2ab. Cos A is B square plus C square minus A square by 2bc. Cos of any angle is nothing but sum of the squares of the sides connecting. I hope it is clear, right, sir? All the basic concepts we discussed. Now comes the application part. We'll try to solve as many questions as possible based upon the application. Application of geometric center concepts. Side heading, write down, sir, application. Before I discuss application, we discussed centroid, we discussed circumcenter, we discussed incenter, and we discussed orthocenter. Excenter may or may not come in your exams in a high level workshops which we will discuss. We will discuss sine rule and we discussed cosine rule. In center, circle radius is smaller, circumcenter it is capital R. Here it is nothing but Apollonius theorem to find out the length of the median. Apollonius theorem to find out the length of the median. Apollonius theorem to find the length of the median. Right? Problems. First one. The length of the sides of a triangle. We'll try to solve 12 to 15 questions. Length of the sides of a triangle. Length of the sides of a triangle are 12, 35 and 37. 12, 35 and 37. Find the length of the median drawn to the longest side. Find the length of the median. Find the length of the median drawn to the longest side. Find the length of the median drawn to the longest side. If the length of the sides of a triangle are 12, 35 and 37, find the length of the median drawn to the longest side. Solution. Do not apply Apollonius theorem in hurry. Don't apply Apollonius theorem. It will take time. Apollonius theorem is time consuming. It takes a lot of time. Now if you observe very carefully 12, 35 and 37. Yesterday we discussed how to find out Pythagorean triplets. We discussed. What is that? Take a side even number 12. Square it and divide by 4. 12 square by 4. 144 by 4 is 36. If the side is even, subtract 1 and add 1. Subtract 1 and add 1. 12, 35, 37. 12, 35 and 37. So 12, 35, 37, it's a Pythagorean triplet. In a Pythagorean triplet, largest side is nothing but hypotenuse. Largest side is nothing but hypotenuse. Largest side is nothing but hypotenuse. Find the length of the median. In a right angled triangle, that means it is not a triangle, it is a right angled triangle because it is forming a Pythagorean triplet. In a right angled triangle, length of median is nothing but circumradius, which is half of hypotenuse. 37 by 2. What is the answer? 18.5. 37 by 2, which is nothing but 18.5. Which is nothing but 18.5. Length of the sides of a triangle are 12, 35 and 37. 12, 35 and 37. These 12, 35 and 37 is nothing but the sides of a right angled triangle. Take the smallest side 12. 12 square by 4 is 144 by 4, 36. Subtract 1 and add 1. 12, 35 and 37. It is a Pythagorean triplet. This is a Pythagorean triplet. In Pythagorean triplet, the largest side is nothing but the hypotenuse. So circumradius is half into hypotenuse. Circumradius is half into hypotenuse. So answer is half into 37, which is 18.5. Half into 37, 18.5. I hope it is clear, right, sir? First question. Any doubts? Second question. If the area and a perimeter of a right angled triangle, if the area and a perimeter, length of the median is nothing but circumradius, Milan, right? Length of the median, right? Length of the median is nothing but circumradius. In a right angled triangle, that is what I said, length of the median. Please, in the theory you should concentrate. You said that you are aware of this. When you are aware of this, you should not ask this doubt. Better, right? Length of the median in right angled triangle is nothing but circumradius. That is the reason I concentrated on basics for the first half of the class. If the area and perimeter of a right angled triangle, are 40 units square and 40 units, 40 units square and 40 units, find the hypotenuse. Second question. Find the hypotenuse. If the area and a perimeter of a right angled triangle are 40 units square and 40 units. Area and a perimeter, right? The first thing, whenever we are solving a question, we'll underline the important key points. It is a right angled triangle. Area is given and perimeter is given. Now we know two concepts. Delta is nothing but R into S. R is nothing but semi-perimeter minus hypotenuse. R is nothing but semi-perimeter minus hypotenuse. Delta is nothing but 40. Total perimeter is 40. Semi-perimeter is 20. R is nothing but 2. R is nothing but 2. 2. Semi-perimeter is 20. 20 minus hypotenuse. Hypotenuse is 20 minus 2, 18. Very beautiful question which makes us understand the concept of two questions. Delta is R into S and in radius is semi-perimeter minus hypotenuse. In radius is semi-perimeter minus hypotenuse. In radius is semi-perimeter minus hypotenuse. Idea clear, right? Third question. one by one different varieties of questions, the different way of solving the questions we will see. Delta is r into s and in radius is semi-perimeter minus hypotenuse. Semi-perimeter minus hypotenuse. Third question. In triangle ABC. In triangle ABC. O is the orthocenter. O is the orthocenter and I is the incenter. O is the orthocenter and I is the incenter. Find angle BIC. If angle BOC is 130 degrees. Angle BOC is 130 degrees. I is the incenter, O is the orthocenter. If angle BOC is 130 degrees, find angle BIC. I is the incenter. Again a conceptual understanding of properties. Again a conceptual understanding of properties. Angle BOC is nothing but 180 minus angle A. Angle BIC is nothing but 90 plus half angle A. 90 plus half angle A. So it is 130. 130 is nothing but 180 minus angle A. Angle A is 50 degrees. Angle A is 50 degrees. Angle BIC is nothing but 90 plus half angle A. Half into 50, which is 115. Again an understanding of two concepts. Again an understanding of two concepts. Two applications of this concept. Angle BOC is 180 minus angle A and angle BIC is 90 plus half angle A. Application of these two concepts. Application of these two concepts. BOC is 180 minus angle A, BIC is 90 plus half angle A. Fourth question. The sides of a triangle are 6, 8 and 10 units. 6, 8 and 10 units. Find the area formed by. Find the area formed by. Find the area formed by centroid, in center and circumcenter of the triangle. In center and circumcenter of the triangle. In center and circumcenter of a triangle. The sides of a triangle are 6, 8 and 10 units. Find the area formed by centroid, in center and circumcenter. Very, very good question, sir. Very, very good question. The sides of a triangle are 6, 8, 10. Find the area formed by centroid, in center and circumcenter. First thing, the sides are 6, 8, 10. 6, 8, 10 are nothing but the sides of a right angled triangle. These are the sides of a right angled triangle. These are the sides of a right angled triangle. So these are nothing but this is 6 and it is 8 and it is 10. Best way to solve this question is by using coordinate geometry concept. We will use a coordinate geometry concept. Coordinate geometry concept. These are nothing but 0, 0. This is 8, 0. This is 0, 6. X-axis and y-axis. First one, in radius. In radius is nothing but semi-perimeter minus hypotenuse. In radius is nothing but semi-perimeter minus hypotenuse. So it is nothing but 6 plus 8 plus 10 minus 10. So in radius is 2. In radius is 2. This is 2 and here also it is 2. In radius is 2. In radius is 2. So x-axis and y-axis in center, whether it is x-axis or y-axis, we got two values. It is 2 and these also 2. Incenter is 2. What is the next one? Circumcenter. Circumcenter is nothing but midpoint of the hypotenuse. So RD is nothing but half of 10. So it is 5, D is 5. I hope it is clear. In center we got, circumcenter we got. What is the next one? Centroid. Centroid, how to calculate it? Centroid is nothing but first is 0, 0, next is 6, 0, next is 0, 8. So if it is x1, y1, x2, y2, and the next is x3, y3. So centroid is given by x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3, x1 plus x2 plus x3 by 3, 0 plus 6 plus 0 by 3, next is 0 plus 0 plus 8 by 3, which is nothing but 2, 8 by 3. 3 points we got. Now let us see how to solve it. 3 points we got. I hope it is clear. In center is semi-perimeter minus hypotenuse. Circumradius is half of the hypotenuse. Circumradius is half of the hypotenuse. Centroid is given by x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. What are the points that we got? The points which we got are 2, 2. Next it is 5, 5 and next it is 2, 8 by 3. First we will do a traditional method. In the next problem I will discuss a shortcut. Traditional method. Traditional method, if the area is given, if it is x1, y1, next is x2, y2 and next is x3, y3. Area is given as half of x1 minus x2, x2 minus x3, y1 you don't need to do this in the second problem. I will discuss the shortcut. This is nothing but half of 2 minus 5, 5 minus 2, 2 minus 5, 5 minus 8 by 3. Traditional method and optimal method. I hope it is clear. x1, y1, x2, y2. Apply this. I will tell you an A and C method in the next problem. I will tell you an A and C method in the next problem. In the next problem, we will discuss the A and C method. Circumcenter is nothing but half of the hypotenuse. In radius is semi-perimeter minus hypotenuse and centroid is sum of the three x coordinates divided by 3, sum of the y coordinates divided by 3. Idea clear, right? Now please write down this question. Sir, it is taking little more time. Can you discuss a shortcut? Yes, there is a shortcut for that which we will discuss. Please write down a question. Question. What is the area of a triangle? Question. What is the area of a triangle? What is the area of a triangle with vertices? One first question I will solve, second and third you can solve it. What is the area of a triangle with vertices? What is the area of a triangle with vertices? 2, 3, 4, 6 and 7, 4. What is the area of a triangle with vertices? 2, 3, 4, 6, 7, 4. Very easy question. If you know this ANC method, in less than 20 seconds you will get the answer. In less than 20 seconds you will get the answer. In less than 20 seconds you will get the answer. See here. 2, 3, 4, 6, 7, 4. I will shift this point by minus 2, minus 3. If I shift it by minus 2, minus 3, this is 0, 0. This is 2, 3. This is 5, 1. If I shift the figure, if I shift or rotate the figure, if I shift or rotate the figure. If I shift the figure from one point to another, or if I rotate the figure, area of the figure will not change. Area of the figure will be unaffected. Area of the figure will be unaffected. Area will be unaffected if I shift the figure or if I rotate the figure. I got the answer. 1 point is 0, 0. Half. What is the value? x1, y2 minus x2, y1. 13 by 2, 6.5. What is the area if 1 point is 0, 0, 0, 0, x1, y1, x2, y2. This is nothing but, if 1 point is 0, 0, half of x1, y2 minus x2, y1. Half of x1, y2 minus x2, y1. Directly make 1 point 0, 0 to reduce your solving time. 2, 3, 4, 6, 7, 4. Shift it by minus 2, minus 3. 2 minus 2, 3 minus 3. 4 minus 2, 6 minus 3. 7 minus 2, 4 minus 3. 0, 0, 2, 3, 5, 1. Half of x1, y2 minus x2, y1. Half of x1, y2 minus x2, y1. I hope the idea is clear. Directly you will get the answer.